So this video looking at AS statistics continues from the previous video looking at how we calculate and find the quartiles to finding the percentiles and deciles. Now this video will go through what is actually meant by the percentiles and deciles and how we find these values from a list of numbers or from a cumulative frequency diagram or from a histogram. So as well as finding the quartiles, where the lower quartile is the lower 25% marker, the median is the 50% marker, and the upper quartile is the top 25% marker, we can also find what we call the deciles, which are the 10% marker intervals, and the percentiles, which are the 1% markers. Now deciles and percentiles are calculated in a similar way to finding the quartiles. So for example, if a dataset had n numbers, then the position of the d decile will be d times n over 10, and the p percentile will be p times n over 100. So to put that in context of an example, so let's say we had n equals 120 and I wanted to work out what the second decile is going to be, which is basically the 20th percentile. So what I would do is I would do 2, because it's the second decile that I'm wanting, times, and it'll be the total data set divided by 10, which would give me 24. So the 24th number in the dataset of 120 would represent my second decile. If I wanted to work out what the 80th percentile is, then I would do 80 times n, which is 120, divided by 100, and if I just quickly type that into my calculator, I get 96. So then that would tell me that my 80th percentile would be the 96th number in the ordered list. Now this is certainly something that I would definitely make a note of, along with everything else you can see on the screen, but hopefully by working out and using those formulas, and again the key thing is that those formulas won't tell you the actual values of the percentiles and deciles, it will purely tell you what position those numbers are from the list of data that you've got. Now often percentiles and deciles are used to identify top or bottom groups of a set of data. So for example, if you did a test and you got 67 out of 90 and you look at your test paper, now if I go back to my own experiences of being a teacher when I'm handing out test papers, that students will do a list of things, and it's quite sort of guaranteed that this is going to happen. So the first thing a student would do is they will look at their test scores and analyse them themselves. So for example, you look at your test paper, you think, oh, 67 out of 90. Now the next thing you would then want to do is you would then turn around to the person next to you or ask your friends, what did you get in that test? Because that score in its own context doesn't really mean anything. Like, yes, it means that you got, let's say, 23 marks wrong, and it might tell you you got 67 out of 90. But you really want to compare to see, well, is that a really good score? Because all it takes is, if you know someone who got lower than that, you think, oh, okay, well, I definitely beat that person, so I'm not as bad as them. But if you ask someone else and they got, let's say, 89 out of 90, you think, oh, actually, my score's not great, because you've compared it to a higher score. However, if you knew that your score was in the 90th percentile, or the top 10% percentile, then that means that you scored 90% of the people who took the test. So in terms of its context, sometimes how well you do in a test is kind of compared to, or is analysed compared to how everyone else has done the test. Now when you're doing your final GCSEs or your final A-levels or a national test, then these grade boundaries are already dictated to you, and what they do is they look at the percentiles and only have a certain percentage of students who get the top grade, a certain percentage who get the next grade, and a certain percentage of people who fail. So it's the whole, every year you will tend to find that the grade boundaries will keep changing for these nationals tests, although they are relatively quite similar, because you think, well, as a nation, or depending on how big the country is and how many people are doing the test, and the figures are that big that it's relatively going to be similar. So what they would do is they would work out the percentiles, and then from that percentiles they would then decide what the grade boundaries are. So often when you're doing a test, grade boundaries aren't really set in stone unless it's a past paper. However, if it's a brand new test, then they would wait to see how the population have done from that test and then decide what the grade boundaries are going to be based on what we call these percentiles or deciles. So using percentiles or deciles, it's possible to find what we call the interpercentile range, which is often the 10% percentile, the difference between the 10th percentile and the 90th percentile. However, it can be assigned as any other percentiles in terms of groups, so I could work out the percentile between the 40th and the 50th, or the 45th and the 55th, or I could have the sort of 20th to the 80th. However, it's usually, if they are going to kind of tinker with that interpercentile range boundaries, they would state that in a question, but often it's usually, most often, going to be between the 90th and the 10th percentile. So in this example, it's very, very similar to what we talked about. So here we've got 70 students were used as a sample to get the grade boundaries of a maths exam paper. The top 15% would get a distinction, the next 40% would get a pass, and the rest would be classed as a fail. So here are the results of the 70 students. Now the nice thing about this is that the data has already been ordered. So what we've been asked to do is find the grade boundaries for each grading category. So from this we know that we're looking at percentiles because we're dealing with percentages. So the first thing we want to do is we want to work out the top 15%. So for a distinction, we're looking at where P is going to be 85. So here I've got my 70 students. So if I do 85 times 70 over 100, then what I'll do is I'm just going to quickly type that into my calculator, and I get an answer of 59.5. And what I'm going to do is I'm going to round that up to the 60th. Because it's a decimal, it's rounded up to 60. Now, from this, what we then need to do is count where is my 60th person going to be. Well, here we've got 10, 20, 30, 40, 50, 60. So 78 is the pass mark, is the lower boundary, I have to say, for a distinction. Now the next 40%, so that would be the 55th percentile. So here we're looking for the 40, the next 40. So here for a pass, so the pass is where we're looking for P is going to be 55%. And so what I'll do is do 55 times 70 over 100, and I again type that into my calculator. 55 times 0.7. Oh no, I entered that wrong. Yeah, that's right. 55 times 0.7 equals, and it'll be 38.5. So basically I'm going to round that up to 39 because it's a decimal, so it's my 39th number, and my 39th number is 57. So for a pass, you needed to get above and equal to 57 marks, and therefore for a fail, it's any mark between that. So if I was going to write this up a little bit neater, so in terms of the grade boundaries, for a distinction, you needed to get a score that was greater or equal to 78. For a pass, your mark needed to be between 57 as a lower mark, and let's just put S, and 78. And for a fail, it was any mark that was less than 57. And there is your final answer between the two. So what that then would then be used, so for example this sample would then be used as let's say like a national pass mark for that test at other schools. So this school would look at this, they would use this, the exam board would be using this sort of sample of 70 students and using the results and as a way of standardizing scores for all other schools. So from this, let's have a look at how we'd work out the percentiles from a cumulative frequency diagram. Now, in terms of the quartiles, then what we would simply do, so here, I know it's going to be a little bit difficult to see, so here we've got n equals 150. Now if I was working for the median, then the median, what I would do is I'd do 150 divided by 2, which is 75. So I would find where 75 was, which is about there. I would, using a ruler, which clearly I am not, I would go from 75 on the cumulative frequency vertical axis, and once it hits the curve, I would then project down, and it would be this number here that would be my median value. Now for percentiles and deciles I'm going to do exactly the same. So for example, let's just get rid of this so we're not going to get confused, and just get rid of all that. So if I was looking for, let's say the well, let's go for the top 75%, so top 15% percentile. So that's basically p equals 85. So what I would then do is do 85 times by 150 over 100, and simply type that into my calculator. So 85 times 150 divided by 100, and I get an answer of 127.5. And if I round that up to 128, so then what I'm then going to do is find where 128 is, which is just there, and using a ruler I would go up to the curve, so where that's 128, and that's where P85, and then from this I would then project downwards. So in terms of to be in the top 15%, the length would need to be roughly around about 156, I would say, at a guess, but being there. So that's basically telling me the position. So the key thing to remember is that the 85th percentile is not 127.5, it's not 128, but 128 is the position of where that 85th percentile is going to be. And that, like I said, that's how we can then project it. So what you're doing is this tells you the position. So the cumulative frequency are the positions of where you look up, and obviously the x-axis is basically telling you the raw values. Now when we then move on to the next commonly used diagram in stats, which is a histogram. Now finding percentiles from histograms is a little bit more complex. Now depending on what information has been given to you, so from this we know that n is 500. Now if you're not sure about how to convert from a histogram into a table, because obviously we're going to need to know the frequencies of these, then there is a video on histograms which shows you how to do that. In other words, what we need to do is work out the area of each bar. So just as a quick refresh, that the area of each bar equals the frequency. So for example, if we just so between 0 and 2, so 24 is basically the area of that first box, or column I should say, or bar of that from that table. And if I'd repeat the process for each of those 5 bars, it will give me those 5 values. Now again, let's look at, so let's say we're asked to find the 80th percentile, or in other words the 8th decile. So first thing we need to do is work out what position that's going to be in. So here we're going to do 80 times 500 over 100, and again if I type that into my calculator, 80 times 5 gives me 400. So I'm looking for where is my 400th time in this particular set of data. Now from this, what would be useful is if I had a cumulative frequency diagram, but typically speaking I know that my, so here I've got 24, then I'm going to have 90 there, then 290, then 290 plus 140 gives me 430, and then I've got 500. So as I know that the 80th percentile is going to be, let me just get a different colour marker, is going to be in this group here, that I know that my 80th percentile is the 400th person. Now from this group I've got 140, so I need to take out 30 people. So I need to find where the 100th and 10th person in this group is going to be. That's the mark I need to find. So what I then need to do, now this bar is marked out of 10, so it's going to be 10 And if I use a different colour, so let me just write down where the tens come from. I'm going to divide that by how many people there are in that group, which is 140. And I'm then going to multiply that by 110, because obviously I need to take off 30 people because that group has got 430 people and I need to work out where the 400th person is. So if I type that calculation into my calculator, I get an answer of 7.857142, and that's a recurring decimal. So that basically tells me that if I count 7.8, which is going to be roughly around about here, that there is where my 400th person estimated is going to be. And the reason why it's estimated is because we're looking at group data and to work from. So if I had raw data, it'd be more accurate, but because I'm going off group data, always going to be an estimate. So my 80th percentile is going to be roughly 17.857142, which rounded up gives me 17.9 minutes to one decimal place. So that will be the top 20% or the 80th percentile.